What's up, everyone? We're beginning Unit 6 today, which is going to be the first of several units in our study of trigonometry. Okay, here in section 6.1, we're just going to be looking at an introduction into angles, being able to draw angles in standard position, convert degree measure of an angle to degrees, minutes, and seconds, and vice versa. And then we're going to look pretty heavily at radian measure for angles as well. Okay. Briefly, let's discuss the word trigonometry. This is a Greek word. It actually comes from two Greek words put together, trigonon and metron, which, when put together, mean triangle measurement. So we're going to see as we move throughout the unit how the study of trigonometry is closely related to triangle measurement. You're not really going to see it in today's lesson, but you'll see it here pretty soon. All right. An angle theta is being shown on your screen right now. Theta is just a Greek letter that's used to represent the angle, okay? And you create the angle theta by rotating an initial ray, which you see in blue here, either clockwise or counterclockwise to a terminal ray, which is in green, okay? Which direction you rotate that initial ray will determine whether the angle itself has a positive measure or a negative measure. All right, a clockwise rotation would be a negative angle measure, and then a counterclockwise rotation is a positive angle measure. All right. Angle measures can be represented or measured several different ways. We usually use revolutions to measure large angles. One complete circular motion is considered one revolution, all right? And then we often use degrees for our smaller angles. And of course, we know by now that there's 360 degrees in one full revolution, right? Now, first thing we're going to do is we're going to draw our angles in what's known as standard position. So this is when you put your angle in the coordinate plane with its vertex at the origin and its initial ray along the positive x-axis. So this angle that's shown in red here is considered in standard position as long as this is the initial ray of the angle. And of course, this would have to be the terminal. Okay, so let's draw each of the following in standard position as well. All right, 135 degrees. Just give a quick little x-axis and y-axis, and we're going to place that initial side of the angle on that positive x-axis. We know if we rotate that angle counterclockwise and put the terminal side of that angle on the positive y-axis, that would be 90 degrees, right? Well, we need to go 35 or 45 degrees further for a total of 135, and that's going to place the terminal side of this angle halfway into the second quadrant, okay? All right, my second angle is negative 225 degrees. So this time I'm going to have to rotate in the clockwise direction, okay? So we know if we take our initial ray, if we were to rotate it in the negative direction and place that terminal ray on the negative x-axis, that would be negative 180 degrees. Well, we need to go negative 225, so that's 45 degrees further. That's going to place you into quadrant 3, halfway. Right? And what we want to notice is that the two angles we've drawn so far, their terminal rays are in the exact same position, halfway into the second quadrant. So these are considered coterminal angles, which we'll discuss a little bit more later on in this video. Okay. All right, last angle to draw here is 390 degrees. Now we know that one full revolution is 360 degrees, right? So to draw an angle of 390, I need one full revolution, and then I need 30 degrees into a second revolution, okay? So I'm going to show that by, here's the one full revolution and then 30 degrees into the next revolution. And there's where I'd place my terminal ray. Okay? All right, now we mentioned that angles are often measured in degrees, right? Well, we can be a little bit more precise than that, all right? Angles can be measured more precisely by dividing 1 degree into 60 minutes and 1 minute into 60 seconds, okay? So 1 degree is equivalent to 60 minutes, 1 minute is equivalent to 60 seconds, and then that would also mean that 1 degree is equal to 360 seconds. If there's 60 seconds in a minute and 60 minutes in a degree, then there's 360 seconds in 1 degree. Okay, and notice the notation here. I use an apostrophe to represent minutes, and I use a double apostrophe to represent seconds. Okay, so 12.5 degrees, that's the same as saying 12 degrees and 30 minutes, all right? And then notice the notation here, okay? So let's change 145 degrees, 54 minutes, and 18 seconds to where it's into degrees only. And if we can't give an exact value at the end, we want to round to 2 decimals, okay? So I don't want to have a rounding error at the end of my problem here, okay? So what I'm going to do is I'm going to take the 145 degrees, I can leave that alone, but I'm going to add it with 54 minutes being multiplied by a conversion fraction of 1 degree over 60 minutes, okay? And then I'm also going to add that with my 18 seconds multiplied by a conversion fraction of 1 degree over 360 seconds. Okay. And notice how the units work here. All right. I'm trying to go to degrees only, so when I set up these conversion fractions, I'm able to get my units of minutes and seconds to reduce away to where the only units that are left are degrees, okay? All right, so simplifying this a bit, this is going to give me 145 degrees plus 54 degrees over 60 plus 18 degrees over 3600, okay? And then we would just simply punch that all in to our calculator very quickly, and we should get an exact value this time. We don't have to round. It's 145.905 degrees. Okay. All right, now let's go in the other direction. Here we have 78.208 degrees, and we want to convert it into degrees, minutes, seconds, and we're going to round it to the nearest second, okay? So really, I don't have to do anything with the whole number of this angle measure, so the 78, I can leave that alone. I'm focusing on the 0.208 degrees, okay? So I'm going to take that measure and I'm going to multiply it by 60 minutes over 1 degree. Okay, and what this is going to do, it's going to allow the degrees to wipe away. And if I multiply this out, I will end up with 12.48 minutes. Okay, from here, I'm going to focus on the decimal portion of that result, so the 0.48. Okay, I'm going to take that. So 0.48 minutes, and now I'm going to try to convert that into seconds. So there's 60 seconds in 1 minute, right? And I'll get the minutes to wipe out here. And this is going to give me 28.8 seconds. And notice the directions round to the nearest second, so 29 seconds. Okay, so putting this all together, 78.208 degrees is equivalent to 78 degrees, 12 minutes, and 29 seconds. Okay.